Now let's say in this question, we have this body over here, mass m2 on an inclined plane, and there is a coefficient of friction also. Rest is all standard things. That is, pulley has got a radius r, moment of inertia about O is I, this is m1, height is h, it has been released from here. With what velocity this is going to strike the floor? It is the same thing, it's only that is we have introduced now coefficient of friction. So equation for this is m1g minus t1 is equal to m18, and for this t2 is acting this way, m2g sine theta is acting this way, and this is, if this is moving over this surface, then the friction force will reach its maximum value, that is limiting value, and that is mu into n. So n is obviously mg is here, mg cos theta is here, and we know that is friction force, limiting value of friction force is going to be equal to mu into n, that is mu into, for this, if we talk about this, m2g is in this direction, this is theta, m2g sine theta is in this direction, m2g cos theta is in this direction, and normal reaction will be equal to m2g cos theta only. So mu into m2g cos theta, that is the friction force. So for this, it is T2 minus m2g sine theta plus friction force over here. That is what? It is mu m2g cos theta, mu into n, plus mu m2g cos theta is equal to m2 into a. Net force equal to mass into action, that is what we are using it. For this, T1 is acting this way, T2 is acting this way, both the forces, they are tangential forces. So torque, ultimately it is rotating in this direction. So net torque T1 into R minus T2 into R is equal to I into alpha. Also, as we have been doing earlier, so A acceleration of this, and acceleration of this point, they are going to be same. Linear acceleration or tangential acceleration, this moving in a circle also. So we have fourth equation as A is equal to R alpha, which is connecting the linear parameters and angular parameters. Now we have four unknowns, T1, T2, A and alpha. These are unknowns. We have four equations. From here we can find the value of A. Solving it, we can find the value of A. Once the value of A is known, from here to here, we can use equation of kinematics, that is V square minus U square is equal to 2 into A into S, and from here we can find the value of V. Now if we use conservation principle, we'll say that is loss of potential energy by M1, where it goes? It goes in increasing kinetic energy of M1 plus rotational kinetic energy of pulley plus potential energy of M2 plus kinetic energy of M2 block plus, and some energy is lost in doing work against friction over here. Some energy is also being lost over here in doing work against friction. So now we can follow this and we can write the equations. That is, it is going to be losses m1 g into h. For this is equal to half into m1 into v square plus m2 g. If this goes by h, this goes h by along the plane. So this is theta, this is h, this is h cos theta, this is h sin theta. m2g h sin theta plus half m2 into v square plus half I omega square rotational energy of this plus mu mg cos theta friction force into this distance h. We can write this equation, we can just put the values, what's the values they are given, and accordingly we can get the answer.